Hello everyone, this is Ruai PCB, your trusted PCB partner. Today we will introduce the design requirements for single-sided PCBs. In the last episode we talked about several advantages of single-sided boards, but the main advantage is still the low cost. But even though we have the advantage of lower cost, most of the boards we see nowadays are still double-sided. Even for me, when I actually design circuit boards, I rarely make single-sided boards. I usually start with double-sided ones. So let's take a look at what other factors are involved. Well, many skilled PCB designers, or those who know a bit about circuit design, even though they know that most circuits can be completed with a single-sided board, still choose to design them as double-sided boards. So what exactly is the reason for this? Actually, there are mainly two reasons. One is that designing a single-sided board takes more time, and as for the board manufacturing cost, in many cases it's not paid out of their own pocket, so they don't really care how much it costs. After all, the time wasted on designing a single-sided board affects their own income. Indeed, designing a single-sided board takes much more time than designing a double-sided board, and it's also much more difficult. Another point is that if you look at it comprehensively, your time is also a cost. If you waste too much time, even though the board manufacturing cost is lower, for the designer, the overall cost is not actually low. So that's another reason. If you're not specifically trying to learn how to design single-sided boards, generally speaking, nowadays no one deliberately designs single-sided boards anymore. There's also another reason, which is not knowing the techniques for designing single-sided boards. This is easy to understand. The main reason is simply not knowing how, because nowadays most tutorials start with double-sided boards. Plus, the widespread use of surface mount components has also made designing single-sided boards more difficult. So if you want to design a single-sided board, you need to plan specifically for using a single-sided board and find ways to improve the routing success rate. The first point is the impact of components on the routing success rate. The impact of components on the routing success rate is significant. The higher the level of integration of the component, the simpler the routing, and the higher the routing success rate. On the other hand, components with a lower level of integration require more complex routing, which makes designing single-sided boards much more difficult. Take this circuit as an example. When I demonstrated it to everyone before, both the chip and the grouping I used were surface mount components. In order to show you knowledge related to single-sided boards, I replaced them with through-hole components this time, specifically to improve the routing success rate. Also, regarding the impact of circuit structure on routing success rate, for example, in a single balanced machine circuit, a parallel port bus structure has a relatively low routing success rate, while a serial port bus structure achieves a higher routing success rate. In situations where high-speed operation is not required, it's best to use serial wiring as much as possible. This can greatly simplify the circuit routing, making it relatively easier to design a single-sided board. Actually, this is quite straightforward. Parallel communication simply uses more lines. For example, with an 8-bit setup, there are 8 IOs communicating between one chip and another, so there are 8 wires connecting those 8 IOs. For serial communication, if you use a protocol like I2C, there are only 2 wires, so the more wires you have, the higher the chance and likelihood of routing issues or failures. That's why it's best to design for serial communication whenever possible. As for the impact of network routing on yield rate, network routing and synchronous design are among the most effective ways to improve yield. We generally need to put effort into this area. If you don't use network routing and just place components and draw the PCB directly, not only will the yield rate be lower, but it will also be more time consuming and labor intensive. This issue should be quite rare nowadays. In the past I saw some really skilled technicians who would skip drawing the schematic and start routing directly on the PCB. But now, from what I've seen, everyone, including those of us who are just learning, starts with the schematic, drawing the schematic first and then routing the PCB. This also helps to achieve a higher yield rate. Next, make reasonable use of jumpers. For single-sided boards, there is only one layer for routing, so if you really can't find a way through, you need to use jumpers. It's not that the fewer jumpers the better, but rather that they should be used appropriately. When using jumpers, the main goal is to adjust the routing density of the single-sided board. As for the length of the jumpers, it's best if they are multiples of 100 mm, which makes it more convenient when bending the jumpers. When the jumper length is kept within 600 mm, the cost is negligible. You can use clipped circuit pins to make jumpers. This is straightforward. On a single-sided board, as everyone knows, routing is only done on one side. You can't route on the other side. But what should you do if you really can't find a way through? Then you use a jumper, which is essentially like turning it into a double-sided board, except on this side we're just using a jumper. And when the jumper length is between 100mm and 600mm, the advantage is that resistor leads are quite long, so after soldering you can cut off the excess leads to use as jumpers. For example, if I need to connect a wire from this point to this point, let's say I need to connect a wire between these two spots, then I leave two pads here and use a resistor lead to jump across, connecting the two traces and thus achieving a crossover. This was also a commonly used method for single-sided boards in the past. Alright, that's all for today's introduction to the drawing requirements for single-sided boards. If you enjoyed this video, please subscribe to my channel for more content. Thank you everyone.